Welcome. Welcome to the Natural History Institute. My name is Bob Ellis, and I am the program director here at the Natural History Institute. I also want to say hello to people out there in live stream land because this is being live streamed at the moment. And if you want to see this presentation later, you can see it as a video on our website. So if there's a particular part of it you want to kind of capture or go back over, that would be an opportunity for you to do so. Before I introduce tonight's speaker, I'd like to remind you of a couple of programs that we have coming up here at the Institute. The first one is the exhibition that's in our gallery, and that is the biophilia hypothesis. This is a long title, so I had to look. The biophilia hypothesis comes to the periodic table. And this is Deborah Ford's exhibition. It opened on Friday. I think you'll find it fascinating. If you haven't gone in there to look at it, you can come in tonight after the talk, and it'll be up until January the 10th. So I encourage you to take the opportunity to check that work out. And in addition to that exhibition, Deborah Ford is going to be doing a workshop, and that workshop is going to be January the 4th. We call it a field workshop. It'll take place here and down at Granite Creek Park. And helping in that workshop, I'll be helping with that, and then Morgan Ford will be as well. He's a USGS scientist whose specialty is insect macroinvertebrates. Let's see. We have published a book, our first book, The Woody Plants of the Mogollon Highlands, and we are going to have a book launch. The authors of that book are here tonight, Joan Tomoff and Carl Tomoff, right back there. So on November the 21st, we encourage you to come out and celebrate this auspicious occasion, buy a book, get it signed by the authors, and they're going to give a little talk about the process of them writing the book. So please come out on November the 21st. On November the 14th, we're going to have a talk here that focuses on Cuatros Cienegas, a critical wetland in Mexico, and Matt Valente, who is a former collections manager here and who's an instructor at Embry-Riddle University, is going to be giving that talk. And it's a fascinating talk. I've seen it, and I encourage you to come out to see that as well. So, humans are a remarkable species. And we have our flaws. Let me tell you about two. The first one. It is impossible for most humans to understand the depth of geologic time. Most humans really struggle with this. That's a flaw. The second flaw is related to the first flaw. And that is, most humans don't understand the dynamic quality of biotic communities. For example, I think 99% of the people in Tucson would be surprised to know that saguaros marched into Tucson 8,000 years ago. So these flaws pose problems for humans. And it's lucky for us that we have people around like Wayne Ranney, who can explain this to the rest of us so that we get a deeper understanding of it. And that's important because whenever people don't understand the deepness of geologic time and the complexity of biotic communities across time, goofy things happen. And not only goofy, but dangerous things. So we are lucky to have somebody here who can explain these to us. So Wayne is a former adjunct professor of geology at Yavapai College and a freelance science tour guide worldwide. He leads geology-themed river trips through the Grand Canyon and is a lecturer on worldwide expeditions with Smithsonian Journeys. He's also a science writer and the author of many award-winning books, which you can see up here and are for sale after the talk. Carving Grand Canyon and Sedona Through Time. Wayne strongly believes in the power of science to enhance our everyday lives and give meaning and clarity to our earthly existence. So I hope you all will join me in welcoming Wayne.
Well, thank you very much, Bob, for that wonderful introduction. I know I see some familiar faces out there, but I see a lot of new faces as well. This is my first exposure to the Natural History Institute, and what a fabulous facility this is, and a fabulous thing that the Natural History Institute exists. Regarding the lack of understanding of geologic time, I have noticed that those people who have geophobia, if you ask them about time, there's only two moments in time for those people, and that's now and then. And to them, then is this amorphous everything in the past, and it's just a monolithic wall behind them. Folks such as yourself and people who do approach geology, they realize that there are lots of thens. And tonight, we are going to look at a few of the thens that used to exist in Arizona. And as I was putting this lecture together for the Natural History Institute, I thought to myself, what could evoke ancient Arizona more than one dinosaur eating another dinosaur? Actually, the truth is, I didn't really look at the graphic that closely, and I didn't realize that another dinosaur was meeting its demise at the hand of that Dilophosaur right there. I just thought it was a beautiful picture of a dinosaur, and then when we put it up on the screen, of course, it's a much more violent one. But the ancient Arizona, and by the way, the reason I'm sitting down tonight is that I tore the meniscus in my left knee a few weeks ago, and I am barely able to walk. And it was a long hike from Flagstaff to get here tonight. So my knee is really sore, and I usually like to stand when I give a lecture, but I'll be seated tonight. And on top of that, I've got a little bit of a head cold, so I'm so glad that they have the microphone and my voice can project a little bit. But the ancient Arizona that I usually think of doesn't really have to do with biotic communities, but it has to do with geologic communities and these ancient paleogeographic maps that many of you know I've been involved with. And this is the ancient Arizona that I want to talk about. And that particular dinosaur was found from rocks that we know as the Chinle Formation, a Triassic age deposit that can be found at the Petrified Forest. So tonight what we're going to do is we're going to take a journey through the landscapes of ancient Arizona, but just realize that on most of these ancient landscapes, there were wonderful ecosystems and plant communities that existed on these. The exception to that would be all of the geology that we're talking about prior to the Silurian period, when life finally colonized on land. And I'm going to show you a few of these ancient maps tonight that will show what Arizona looked like before we had land plants and animals. So just by way of introduction, this is the physiography or the landforms of Arizona. And when we think of Arizona geologically, we usually think of these three provinces. And the two major ones are the Colorado Plateau to the north and the Basin and Range to the south. And geologists, as well as biologists, have noticed that there's a transition zone in the central part of Arizona. Sometimes this is called the Mountain Province, or sometimes it's called the Mogollon Province, but geologically it's called the Transition Zone. And the Transition Zone has characteristics or rock types that we find on the plateau, but they've been deformed as if they're in the Basin and Range. So it has characteristics of both. By the way, the state of Utah to the north of us also has a transition zone, and believe it or not, Zion and Bryce Canyon National Parks are in Utah's transition zone, even though we commonly think of them as being on the Colorado Plateau. So the transition zone only exists in Arizona, and it especially exists in Prescott, Arizona. And I know this institute very much is focused on the transition zone, mainly from a biological point of view, but also geologically. So when you look at a physiographic map of the United States, you don't see the transition zone here between Yavapai and Coconino counties. You just see the Colorado Plateau next to the Basin and Range. So just realize that as a resident of Arizona, you get an extra geologic province that the rest of the country does not. A lot of the story that I'm going to share with you tonight has its origins from rocks that can still be found on the Colorado Plateau. And here we've zoomed into the Colorado Plateau and outlined it. You can see where Prescott is located just outside that boundary. And the boundary closest to us is the Mogollon Rim. And the Mogollon Rim forms the southern boundary of the plateau. Believe it or not, if you went back in time prior to 20 or 25 million years ago, the Colorado Plateau would have extended down into the transition zone before it got stretched and pulled apart. So we'll focus on the plateau tonight because that's where the rock record resides in this particular sequence. And here, I've got a diagram from the book Ancient Landscapes of the Colorado Plateau that shows the Grand Staircase. Now, maybe you've heard of the Grand Staircase. There's a national monument that has been created that shows this. Even in this diagram, this sort of cross-section from the Grand Canyon on the left to Bryce Canyon on the right, there's still a vertical exaggeration to the Grand Staircase right here. And south would be over on the left and north would be on the right. The state line goes right through there. And these are the various components of the Grand Staircase: the Grand Canyon, the Chocolate Cliffs, the Vermilion Cliffs, the White Cliffs, the Gray Cliffs, and the Pink Cliffs. And from the bottom of the Grand Canyon all the way to the top of Bryce, there's a 3-mile stack of sediment that preserves this ancient history. And let's just stretch that and vertically exaggerate it even more. And you can see here the Grand Canyon, and then we go on up through the various layers of rock all the way to the top there at Bryce. This is a record that lasts about 1,700 million years. There's some major gaps in that record as we look at this stack of rocks, but that's what it is showing. And as we look at this, all of the rocks below the red line can be seen in the Grand Canyon. And everything above that line has been eroded off of the top of the Grand Canyon. I'm sorry, you retired and moved to Arizona before you could see these rocks there. And in fact, I use this diagram on my rim-to-rim hikes. I pull out this diagram, and as we're trudging up from Phantom Ranch and we get almost to the top, but we still have 1.5 miles to go, I pull this out and I tell people, be thankful you didn't do this hike 20 million years ago. You'd still have to climb up to the top right there. But the purpose of this diagram is to show you that in the Grand Staircase and on the Colorado Plateau, there's no one place where you can see all of the stack of rocks. And there's the rocks that are seen at the Painted Desert and the Petrified Forest. And in between those two red lines are what you see at Zion Canyon. There's many places where the Gray Cliffs can be found: Mesa Verde, Black Mesa, or the Book Cliffs. And of course at the very top is Bryce Canyon. And a lot of times when I pull out this diagram at Bryce Canyon and we're standing on the rim of Bryce, I tell people you are standing on top of 3 miles, 15,000 feet of a rock record. And guess what? All of these rocks that you see in the Grand Canyon, at Bryce Canyon, they're down below sea level. And that's because the Grand Staircase is tilted down to the north. And so even though those rocks are at 8,000 feet on the north rim, they're below sea level by the time you get to Bryce. Now for Yavapai County and the Prescott area, this is what you have. In the Prescott and Jerome area, you have those rocks. In Sedona, it's between those two red lines. And then at the very top, you have these things that are the volcanic rocks like Thumb Butte and Glassford Hill. And everything in between here has already been eroded off of the Prescott area. And we'll learn tonight when those rocks were removed and why they are no longer present here. Because you retired here to see these lovely pine and juniper trees, but had you come here about 15 million years ago, you would have had Sedona's red rocks here. So you missed out on that. But at least you could afford living here because you don't have the red rocks. Now, I lied a little bit. There is one place where you can see most of the Grand Staircase. And when you're driving between Jacob Lake and Kanab, Utah, you can stop at this pullout and you can look and see the chocolate cliffs and the vermilion cliffs and the white cliffs and the pink cliffs. And the one set of cliffs that you can't see from the Lefevre overlook would be the gray cliffs. So I put in this secondary picture here that shows the gray cliffs and the pink cliffs. And I put this geologic picture with the horse in there for someone in the audience tonight, and you know who you are, that horse person who sees that. This is actually the Aquarius Plateau, over 10,000 feet in elevation, and that's the youngest part of the Grand Staircase. That's the very last layer to be laid down. So we're going to do a survey through time of the Grand Staircase, and we're going to go back to the oldest rocks in the Southwest. And this is the geologic setting for Arizona and the entire Southwest 1,700 million years ago. And that abbreviation, capital M, small a, stands for mega annum. And mega annum means millions of years ago. So when you see that abbreviation, that's what it stands for. And these rocks of this age are found all over Arizona, and you can see them a lot here. But look at that geography. I do want to point out that I'm going to show a series of maps. And by the way, these are the latest rendition from Ron Blakey. You might be able to pick out the outline of the state of Utah here, the state of Colorado, New Mexico's over here, and there's Arizona. You can see, excuse me, these rocks can be seen in the Bradshaw Mountains. I took this picture from Interstate 17. Don't worry, I was at the rest area. I wasn't driving and taking the picture, although I have been known to do that. And also you can see these very old rocks when you're driving in the Dreamy Draw, very close to downtown Phoenix. There's a wonderful road cut right near the Squaw Peak. The Four Peaks are also eroded remnants of these very old rocks. When you drive over Mingus Mountain down into Jerome on Highway 89A, you go through these very old rocks. And I hope all of you get the chance to go one day to the Black Canyon of the Gunnison River. And that's the painted wall, and we're looking down to the Gunnison River down at the bottom. But this is also an exposure of these very old crystalline rocks. And I'm sure we have a lot of people in the audience tonight who have made the hike down to Phantom Ranch and crossed over the Black Suspension Bridge. And that also is part of these ancient rocks. These are not sedimentary rocks. These are metamorphic and igneous rocks. But believe it or not, geologists can look through the metamorphism of the rocks and see what the rocks used to be. And when you're looking at a rock that is a mica schist, like the Yavapai schist, I took this picture driving into town today, and this is a road cut on Highway 69 just to the south of Dewey, and we're going right through the Yavapai schist. When you look at a schist, the chemical makeup of the schist is exactly the same as shale. And this rock used to be a shale and was likely deposited in the ocean that existed in this part of the world before it was cooked and buried. So as we look at this ancient geography, you can see how different everything is. The yellow circle is the Natural History Institute, and I'll just move that out of the way. But let's zoom in on the state of Arizona, and there you see the outline of the state of Arizona. There's Prescott in the yellow dot. And look at this geography right here. Most of Arizona did not yet exist as emergent land, and it was ocean. But I want to point out these arcs of volcanoes that you can see, because these are little pieces, little microcontinents. They're going to drift in and collide with the underbelly of North America. That one there is called the Yavapai Terrane. And the Yavapai Terrane is a name that is used all over North America because the Yavapai Terrane extends from Yavapai County to the subsurface of Iowa. And I'll show you a map that shows you it. The next outboard volcanic island arc is called the Matazelle Terrane. And I know that the word is spelled Mazatzel, but the old cowboys in Yavapai County over there, they pronounce that word Matazel. So I'll use the cowboy term. And here's a map of the basement of North America. That is our home continent of North America. You can see the outline of the states. And here's the Yavapai terrain, which you see goes from Yavapai County all the way up through Iowa and into Wisconsin. This is part of those island arcs that used to exist to the south. And these island arcs, by plate tectonic processes, moved in and collided with North America. And right behind it, just about 50 million years later, was the Matazel terrain, and it collided with the Yavapai terrain. And I must admit, I am so proud when I go to national conventions of geologists, and somebody from Pennsylvania State is giving a lecture about the Yavapai terrain. And I sit back there and I smile and I go, that's my home terrain. I know the Yavapai terrain, and it's really fun. You can see that they give all of these terrains various names. There's the Mojave terrain, and the Ouachita origin is a mountain building event that created the Ouachita Mountains. Down on the bottom of the Grand Canyon is where we have some of the best exposures of these crystalline rocks, and you can see the nature of the schist. All the mica minerals have lined up to create that platy foliation. And these rocks were created 13 miles below the surface of the earth. The reason we know that is there's garnets in the schist, and the garnets can only form at certain temperatures and pressures, and today those temperatures and pressures are found 13 miles down. Rocks that were even deeper than 13 miles got hot enough to melt, and when those rocks melted, they rose up as liquid magma, and they invaded the black schist as these pink magmatic dikes. And how interesting it is. Here's a picture of the Himalaya mountains in a storm, and it's just meant to represent that that's 10 to 13 miles down, not 1050. That should be a T in there. 10 to 13 miles in the earth. So these rocks are back at the surface. When you drive through that road cut in Dewey and you see the sun glinting off of that Yavapai schist, that rock used to be 13 miles down. And 13 miles of material was eroded off of it to bring it back to the surface. We're going to jump way forward in time now because we want to get into the sedimentary record. And there's where Prescott is located. And this is 505 million years ago. And I hope you can see the outline of the southwestern states. We don't even finish over here with the outline of California, because California is just a gleam in Mother Nature's eye. Where you see this change in the blue color right there, that actually represents the boundary of North America at this time. And the edge of North America was flooded with seawater, and this light blue color represents very shallow ocean water, and the dark blue color represents deeper water. So if this was the edge of North America at the time, you can see it goes right up there into central Nevada and on up into Idaho. The rest of the western part of the United States is going to get added on later as other island arcs collide with that edge of North America. If we move up through the stack, we also have a record for tropical seas, and the red wall limestone is a very prominent layer of rock that exists not only in the Grand Canyon shown here, but it's also present in the Verde Valley. And in fact, the red wall was mined to make the cement for Glen Canyon Dam. So the next time you go look at Glen Canyon Dam, you're actually looking at repurposed red wall limestone. And red wall limestone, whoops, I got these out of order here. We're back to 505 million years ago. And this is the surface. Let me go back to that. This is the surface where these Vishnu mountains were eroded. This is actually the Vishnu and Yavapai schist right here, but you'll notice that it's eroded down very close to sea level. And there's where Prescott is located. Prescott used to have beachfront property. If you ever get a ride back on the time machine, you want to set the dial to 505, and you'll be right here at the beach. This is the map for the red wall limestone. And let's just zoom into Arizona right there. And you can see that almost the entire state of Arizona is covered in shallow tropical water. And I'm not going to show you all the maps for the upper layers of the Grand Canyon here, but I do want to share with you the one map for the Hermit Formation, which forms this red slope just about a fourth of the way down into the Grand Canyon. And this is the map for that. This is during the Hermit Formation time. That's where Prescott is located. And there's an ancient mountain range that is up there called the Ancestral Rocky Mountains. Nobody ever saw the Ancestral Rocky Mountains. They were completely eroded away after sitting on the landscape for 150 million years. But we know they were there because of the sediment that was washed out of them. And the sediment is the Hermit Formation. So that's the stuff that came out of the mountain range. That's South America down there. And you can actually go to where the Ancestral Rocky Mountains used to be, and that's the Black Canyon of the Gunnison. And as you look at this picture from the south rim of the Black Canyon, there's the roots of the Ancestral Rocky Mountains, those Precambrian rocks. That's how far down the erosion went. That's the erosion surface that formed about 165 million years ago. And then those sedimentary rocks buried the roots of the Ancestral Rockies. That is a fantastic unconformity right there. The amount of time that is missing in that gap right there is about 1.6 billion years of the rock record that's missing there. All of the rocks that are found in the Grand Canyon and the petrified forest have already been stripped off that surface when that upper layer of deposit was there. And I've got a close-up of that contact right there. There's the eroded top of the Ancestral Rocky Mountains. I just thought I would share with you how these maps are made, because this is really a fantastic way to really picture how our Earth and our home continent of North America has changed through time. By the way, on this map you can see the outline of the country of Venezuela and Suriname, and these are the West African countries, Mali, Algeria. This is when Africa and South America used to be connected to North America. Here's Arizona. There's Wisconsin. I know we have somebody from Wisconsin. Go ahead and say it. Go Badgers. And then we have Michigan over here and Ohio. But you'll notice this orange color here. This represents wind-blown sand. And in the state of Arizona, for this particular projection in time here, we had very arid conditions. And then where you see more of the green color, it was more humid. Now, the way these maps are made is that somebody who doesn't have a social life takes vast amounts of geologic data. And let me tell you, if you have trouble sleeping at night at the high elevation of the Mile High City, pull out your copy of The Evolution of the Pacific Ocean Margin, and that'll put you right to sleep. But somebody has to go through all of this information. Think about it. Thousands of geologists are publishing data about what the environments were in Western Australia at 312 million years ago. And then they're also publishing about what it was like in New South Wales and Hunan province in China. You have to put together all of the areas on the Earth for all of the thens in the geologic past. And what happens is you collect all that information and you synthesize it, and that's the man who has done that, Dr. Ron Blakey, Professor Emeritus at Northern Arizona University, and he makes these into digital images. And he has retired from teaching at NAU, and he now has his own business going gangbusters, selling these paleogeographic maps to oil company geologists who eat it up, because by looking at the ancient environments, which remember are written or made because of the rock record, it tells them where the seas were and where the shorelines were and where the oil might be. So the way that Ron does it is he starts with a blank canvas, and you'll notice that on all the maps that have the Southwest, not only are the state lines drawn, but all of the county lines. And this is really great if you're from Yavapai County, because as you know, the Yavapai County line goes right through the town of Sedona. And half the people in Sedona live in Coconino County, and half live in Yavapai County. So you can obviously identify where Prescott is located. And what happens is you start out with a blank map, and then using all of this geologic information, the first thing you do is you color in where the seas are going to be for this particular slice of time. And the different shades of blue represent the different depths of the water, okay? So we have deep water at the bottom and shallow water at the top. Then you put in the land elements, and the land elements might involve coastal floodplains colored in brown, or they might be wind-blown sand dunes, which we have a big record of from the past. And if you look closely, you'll actually see dunes. You'll actually see a dune pattern on these right there. And you know why? Because for every single landscape that he grabs, he actually is taking space photographs of modern dunes in the Sahara and then superimposing them over the space map. And it really makes it look realistic. He also does the same thing with the mountains. And here's a projection of the ancestral Rocky Mountains. And remember, this has nothing to do with the modern Rockies. This mountain range was completely beveled and eroded away before we got here. It was beveled and eroded away 165 million years ago. And same thing there. Now the ancestral Rocky Mountains formed because of the collision of South America with North America. So what Ron did is he went to the space photographs of Pakistan and India, where India is colliding with Asia, and he pulled images of mountains from there. So that's how the maps are made. So as we move on in our time process, we're getting to the age of dinosaurs, and we even have some global maps in our book. The yellow dot represents Prescott, and this is North America. Believe it or not, this is Europe. Africa is located here, and this is South America. You can see these little linear lakes that are starting to form right on top of the Appalachian Mountains. This is where Europe is beginning to pull apart from North America, and these basins are forming. Now, for all of the time that we have talked about so far, except the Vishnu Mountains, the western side of North America has been very quiet geologically, and it's been a boring place geologically. There hasn't been earthquakes, there hasn't been volcanoes. But right at this time, about 225 million years ago, when Pangea begins to split apart, North America pulls away, and all of a sudden this becomes an active margin. And this could be what Arizona looked like geologically. This is where Arizona would be located at this time, and this is going to be the future California right there. So the Earth's lithosphere, which we know as the Farallon plate, was being shoved underneath the edge of North America, and big volcanoes were blowing off in California and southern Arizona at this time. And this is what the paleogeography of that time. This is the subduction trench right there, and here are the volcanoes that formed on top of that. Prescott's located right here, and all of the ash that was coming out of these volcanoes spread off into the petrified forest area, and this is where the petrified logs originated, and this is the way the rivers flowed in that time. And we have the evidence for this by the way the sediment is structured and architectured inside the Chinle Formation. But the other reason we know it is that the petrified logs, their root balls are always found in the upstream direction, and the tops of the trees are swinging in the downstream. So when these big trees were ripped up in a flood, they would move down and create log jams, and then the tops of the trees would swing around since they were lighter. And it all comes from this deposit, the Chinle Formation, which is so rich in this petrified wood. And some of the preservation is fantastic. Look at the knot in there where a branch was growing out of the tree. So this is all from a time period known as the Triassic. If we go to the next time period, thank you Steven Spielberg and Michael Crichton for making this word a household term, the Jurassic. The Jurassic was a time of great aridity on the Colorado Plateau. We had giant deserts everywhere. And if you've ever been to Coyote Buttes or the Vermilion Cliffs up there, this is where this photograph was taken. These angled lines that you see are the leeward sides of ancient sand dunes. And whichever way the beds are dipping, that's the direction the wind was blowing. If we look at a global projection of the Earth at this time, this is what it looked like during the Navajo sandstone time. And think about that previous map we saw. Africa has now pulled away and created this little bit of Atlantic Ocean. Would have been great to do a transatlantic flight in those days, just an hour or two. South America is pulling away and creating the Gulf of Mexico. Look at how humid it is up here in Greenland and Arctic Canada today. But where you see these earth tones running through here, this is the great arid belt of the Jurassic time period. And if we zoom in a little bit to the American Southwest, there's where Prescott was located. All of this was windblown sand, and now you can see those dunes really easily in this projection right there. Those were actually dune fields that are from the Sahara Desert, and they were covering all of Arizona at that time. I took this picture in Western China today, and that's what Prescott looked like 180 million years ago. So I don't think many people in the audience tonight are going to set the time machine for 180. I don't think people want to come here and live in a sand dune. But you might go vacation there, okay? So let's say that Prescott is a vacation spot at that time. You know, part of the reason we're able to tell these ancient histories is because geologists can look at known deposits that are laid down in the present. And then when they find the same kind of architecture in a layered rock from something that's hundreds of millions of years old, they can project that maybe it formed in the same way. And look at this deposit from Hurricane Katrina in the year 2005. And you can see how the sediment is structured in here. This is a hurricane surge deposit. And if you were to find a lithified sandstone or shale that had this kind of architecture in it, you could then make the interpretation that maybe it formed in a hurricane surge. So we take modern deposits and we use them to know what happened in the past. And for this particular deposit, if nobody was here to record this, we would know that this deposit had to have been laid down after the year 2002, because that's a 2002 Crown Victoria right there. And you can't just shove the car underneath the deposit. The deposit has to be there first, and then you pile the stuff on top. So what I mean to tell you is that if you ever run into people who are geophobic, tell them to get over it. All of this stuff is just common sense. You just have to think it through a little bit, okay? And don't let people get upset about geology. The very last time period in the age of dinosaurs is something called the Cretaceous. And I'll let you in on a dirty little secret. The movie and the book should have been called Cretaceous Park, because all of the dinosaurs except for one were Cretaceous dinosaurs. But Michael Crichton thought that the word Jurassic just rolled off your tongue a little bit better. And the Cretaceous was a time of wet and humid conditions all over planet Earth. So guess what? We don't have red sandstone and shale for Cretaceous rocks here. We have gray shale because it was wet and humid. And when you look at the global projections for the Cretaceous time period, just about everywhere you look in North America, you see these very humid and wet conditions. And during the Cretaceous, there was no polar ice caps in Antarctica or in the north. And so all of the water that's currently tied up in ice was in the ocean basins and flooding the lowest parts of the continent. So this is North America, but there's a giant seaway that stretches from the Arctic Ocean all the way to the Gulf of Mexico. If we zoom into our part of the world, you can see that there was barely any land in Arizona, and it was surrounded on two sides. On the left or the west side was the Pacific Ocean, and this is called the Great Interior Seaway. And this is where the Rocky Mountains are going to pop up in the not too distant future right there. But at this time, it was covered under this water. And there's a close-up of the state of Arizona at this time. And then finally we come into when the modern landscape emerges. This is a picture of the granite dells. And at that time when we were back there about 70 million years ago, the rivers in this part of the world and the landscape was completely inverted from what it is right now. And this is what the geography looked like 70 to 52 million years ago. And we had mountains to the south and west, and the rivers used to go out in that direction away from Prescott. So this is the period of time when this great sedimentary stack was eroded off of the Sonoran Desert. When you go down to Phoenix and Tucson, you might see some volcanic rocks on the landscape, but what you mostly see are the Precambrian rocks that are exposed because all of the sediments that we see in the Grand Canyon and the Grand Staircase were eroded off of the Mogollon Highlands. Now, nobody ever saw the Mogollon Highlands. They were destroyed completely by about 20 million years ago. But we know they were there because all of those rocks are gone from areas south of here. Even Prescott does not have these anymore. And then beginning about 60 million years ago, the Rocky Mountains popped up. So even though the rivers were still coming out of the Prescott region and going onto the plateau, the water was ponded in these freshwater lakes. And when the Rocky Mountains came up and blocked that. And another thing that was going on, we had the Sierra Nevada granite that was being intruded. And what caused the Mogollon Highlands to come up was a mountain building event known as the Laramide orogeny. It was named after the Laramie Basin up in Wyoming. And it lasted from about 70 to 40 million years ago. Orogeny is just a fancy jargon word for mountain building event. And the word ore comes from that. When you hear of gold ore or silver ore, the original Greek word ore meant to do with mountains and minerals. So people will sometimes ask me, Wayne, what is the shortest amount of time that I could go backwards and not recognize that I was in Arizona? And I thought about that quite a bit, and from the geologic history that I have learned, it's about 20 million years ago. You could go back 20 million years ago, and the Mogollon Highlands were still present, although they were greatly eroded, and you would be going down into a valley towards Sedona and Flagstaff. And I'll guarantee you, you would not know you're in Arizona with that kind of a situation. But beginning about 20 million years ago is when the modern landscape began to emerge. And what happened is that the Earth's crust was being stretched, and central and southern Arizona became faulted. So the exact spot where the Mogollon Highlands used to exist now became faulted and downdropped, and we inverted the landscape. And that's why the Phoenix Basin sits lower than Prescott and Flagstaff. And all that began about 20 million years ago. It's still going on to a certain extent, and we're getting a lot of erosion and faulting down there. And guess what the last thing to happen in our landscape forming event was? The very last thing to happen was the cutting of the canyons. Most of the canyons are no older than 10 or 15 or 20 million years old. There probably are some canyons that are a little bit older than that, but most of the canyons we see are young. And we can even talk about some younger features that happened in the Grand Canyon, like these spectacular lava flows that have erupted all within the last 1 million years. And the Grand Canyon was already in existence to the depth that we see today when these lava flows poured off the rim of the canyon and spilled into the canyon, into existing canyons. Look at that lava cascade over here as it comes down. And this one here is filling a canyon. That used to be a canyon that came into the Colorado River at grade, but it's been filled in. So we had an artist develop this cartoon that shows what it would have looked like, because on 17 different occasions, the Colorado River was dammed by lava flows. And once the lava flows came and dammed the river, these reservoirs would back up into the Grand Canyon. And I just want you to think about that magical field trip that the Natural History Institute could do from 500,000 years ago. And you go camp on the rim of the Grand Canyon right there, and across the way you see red hot lava pouring off the rim of the canyon down towards the Colorado River. And that red hot lava gets to the Ice Age Colorado River, and all the steam comes up. And you're camped up there and you're looking at it and you go, that's spectacular. And then the camping trip lasts a little bit longer and you see the big reservoir start to fill. And then you happen to be camping there long enough that the reservoir is full and a huge 500-foot waterfall is pouring over the lava dam. And then before you leave, you actually see the lava dam be destroyed. Because on at least 5 different occasions, we have evidence that the lava dams failed catastrophically, meaning that the dam gave way all at once. And we have deposits that are 600 feet above the modern river with boulders as big as this room sitting in the deposit. And that's the remnants from these big floods. Well, the Hohokam lived next to the Salt River down there in the Phoenix Basin. And, you know, they lived down there about 600 years ago. And before then, they were there from about 1,200 years to 600 years ago. And believe it or not, they lived on the exact same landscape that we live on. Geologically speaking, 1,200 years ago is nothing. They saw every shape to every mountain that you know in Arizona. And as you think about these ancient landscapes, this is the modern drainage of the Colorado River, and you'll see that relative to that other diagram we saw, the river is going in the exact opposite direction it was going 70 million years ago. And the modern landscape has emerged. Think about it. This is the one frame in the movie that all of us get to enjoy. But because you landed inside the movie in the 21st century, we are able to go back in time because of this geologic awareness that we have. And what I'm going to do right now is I'm going to show you a sequence of maps that progressively go back in time. And you can watch the evolution of the southwestern states. And this is the present landscape. This is the oldest map that we have. The projection of the continent will be exactly the same on every map. So just that little panhandle of Oklahoma will always be in that position. You can see it there, and you can see it there. And let's just go backwards in time in the American Southwest. And don't bother about the time down there. Just watch the landscape change. Now, Ron Blakey has made every single one of these maps so that you can see how the landscape has changed through time. There's the freshwater lakes. And remember that climate is also embedded in these maps. Where you see it get green, this is where the climate is very wet and humid. And I have stopped the cartoon right at this spot because about 55 million years ago is when the gold of Yavapai County was emplaced. And when the Mogollon Highlands were uplifted down here, there were intrusions of magma that came on up into the crust. And this is when the mineralization in Arizona happened. So we'll continue with our survey of the southwestern United States. There's the Western Interior Seaway. You can see we have a great record of this. We have lots of deposits from this particular time period, and it shows us that that seaway was moving back and forth. Now the interior seaway is gone, and now these ancient rivers are headed directly north. This is during the famous Morrison Formation, which has all the dinosaur fossils on the Colorado Plateau. Now we come into the Jurassic. Look at the colors that are present there, because the rocks document that this was an arid Sahara-like desert. No, we don't put the lines of latitude here. They could be put there, but because we've held the continents still, you would see the lines of latitude moving on each map. And right now we're very close to the equator. I've also paused it here at 225 million. These are the petrified forest rocks. And there's these rivers that were coming out of Texas and old Mexico, making their way to the shoreline in Nevada. Now we haven't even gotten to the Grand Canyon rocks yet, but as soon as we get to 270 million right there, there's the Kaibab limestone and what the geography was at Kaibab limestone time. So now each map is going to project the layers of the rock that are in the Grand Canyon. And of course, other things were going on elsewhere, not just in the Grand Canyon. These are all little bits of Nevada, Idaho, and Oregon that are going to attach to North America. Redwall limestone there. That's the greatest extent of the sea. You can see that most of Arizona is located in very shallow water. And we're just going to finish up here with the last few hundreds of millions of years. Now this is a time when there's no land plants, so you won't see any green on the projection here because there's no land plants or animals at this time. And that's all I have for you tonight. Thank you all very, very much.